Right, and a square will come from here. 1 a square is left over. All right, this is cos theta into within bracket 1 plus sin theta into d theta divided by this value, which is a square common, because a4 if I take outside it will come out as a square, and within bracket it is 1 minus sin square theta. This 1 minus sin square theta under the square root will be cos square theta, and this cos theta and this square root value cancel out. Okay, so we are left with twice a square, because it's 1 a4 and a square, we left with a square only, twice a square. This is 0 to pi by 2, and this is 1 plus sin theta into d theta only. So what is the leftover value? Okay, it will be theta plus cos minus cos theta integration. Okay, so final value is, let me write here. So final answer of this will be twice a square. Integration will be theta plus minus cos theta, because sin theta is integrated as this is minus cos theta, and 0 to pi by 2 limits. It is twice a square. Here it is pi by 2. I think 2 is also cancelled out, but because this 2 in the denominator was there, and then 1 2. Okay, let me check. So this is pi by 2. Okay, so 14th question is solving. So this is minus minus plus, because at pi by 2 cos 0 is 0, cos pi by 2 is 0, cos 0 is 1, so this is plus 1 only. So 2a into pi, 2a square into pi by 2 plus 1 is the answer. If I multiply this inside, it will be pi a square plus 2a square is the final answer. If 2 is there, I think it is a square into pi by 2 plus 1, or 2a square into pi by 2 plus 1. This is the final value, required area of the given curve here. The 14th question is 2a square into pi by 2. Okay, this is 100% true answer. 2a square into pi by 2, this is the answer here, or this is the answer. So either of this can be the answer here. 2a square into pi by 2 plus 1 is the area of the required figure. 14th question is done. Now let me talk about 15th and 16th questions, which are also very important questions. Now let me take 15th question first. Now question number 15th here. It says find the area or bounded the curve x square plus this. Again, this is x by square is equal to 4a square. 4a square within bracket it is 2a minus x or something else. 2a minus x, okay. And its asymptotes. Area bounded by this curve and its asymptotes. This is the value given to us, and its asymptotes here. Okay. So again, at x equal to 2a, the asymptote is there, as y square is 0. If I divide it by x, okay, so at x equal to 0, it may be the asymptote here, no problem. Let me solve it. So this equation is, okay, even powered in y square, so curve is symmetric over x-axis. Solution, let me find out. First one, curve is symmetric. Curve is symmetric about x-axis, as y is even powered. Second point, it will pass through the origin. No, sorry, constant term is there. It will not pass through the origin. It will not pass through the origin. Not pass through the origin. Why? Because constant term, independent constant term is 4a into 2a, 4a square into 2a, that is constant term, independent constant term, so it will not pass through the origin. Third point. Okay, now putting y equal to 0 here, putting y equal to 0, if I put, we will get 2a minus x equal to 0, or x equal to 2a. X equal to 2a is a, we can say, tangent line, or x equal to 2a is the point at which the curve will meet the x-axis. So let me check it. So at 2a 0, x we have solved. 2a 0, the curve is meeting. The curve will meet the x-axis. Curve will meet the x-axis at this point 2a 0. Okay, so curve is meeting the x-axis at this point here. Undoubtedly that is there. Now asymptote is at what point? Because of solving this equation for y here, solving it for y square. So y square here is equal to, this is 4a square into 2a minus x divided by x here. So for x equal to 0, okay, the y square is infinity. At x equal to 0, y square is infinity, or y is plus minus infinity here, or y is plus minus infinity. Y tends to plus infinity, or y square tends to plus infinity, but y tends to plus minus infinity, and plus infinity. But x equal to 0, it means y-axis is the, at x equal to 0, y-axis is the asymptote here. So y-axis is the symmetric, is the asymptote, here. Okay, and at x equal to 2a minus x, the curve is passing through. So let me draw the curve here. For the curve here, the curve is of this kind. At this point, let me take this is 2a 0. The curve is intersecting or meeting the x-axis. This is the x-axis, origin by the x-axis. So if I take the curve here like this, so at x by axis, this is the curve here. Okay, by axis is the asymptote here. So this is the curve. I'm sorry. This is the curve here. Okay, so we have to find out the area of this curve. Now let me take, this is the strip, elementary strip here. This is P, Q, and this is M and N points. And this distance is dx. The length of this strip is, width of this strip is dx. Okay, and the coordinates are y and x. So the area here of this curve, area of the required curve, is equal to twice into, this is, let me take A, O, and this is B here, let me take OAB again, twice into OAB, area of OAB, twice into area of OAB. Okay, so this is nothing but twice into limits 0 to 2a. Okay, by into dx. So this is symmetric about x-axis. So this is y into dx here. Y into dx. Let me find out this area then. So finally, the area is this. So area is equal to 0 to 2a, 0 to 2a into y into dx. Y is here, this value. This is 2a because 4a square root under the square root twice a minus x divided by x under root x here into dx. Okay, because this is the value of y from this given equation. Okay, now let me solve it. So putting x equal to 2a sine theta. 2a sine square theta, sorry. So 2a sine square theta, if I substitute, then this value can be solved. So finally area is this, okay, that by the curve here. So finally putting here x equal to 2a sine square theta. Therefore differentiating it with respect to theta, so we get dx equal to 4a sine theta into cos theta into d theta. Limits, if I putting limits at x equal to 2a, theta equal to pi by 2, because again 1 it will be 2a upon 2a is 1 sine square theta, 1 sine theta is 1, sine theta equal to 1 means sine pi by 2, so theta equal to pi by 2. So at x equal to 0, theta equal to 0. So limits are here, twice 0 to pi by 2, limits, this is twice a here, and under root twice a minus twice a sine square theta inside the square root, okay, into, then we put here the value, and this is into 4a, this sine theta into cos theta d theta, divided by the value here x we substituted under root 2a sine square theta. The square root from sine theta will cancel out, so under root 2a will left over. This under root 2 cancel out, okay. So we are left with, so this sine theta and this 4a and this 2a and this 2 is 16a square, 2 to the 4 for the 16a square. And this from inside the square root we will get under root 2a, under the square root 1 minus sine square theta, divided by this under root 2a in the denominator also there, and sine theta is there, into, now this is sine theta cos theta d theta. 1 sine theta cancel out, this 2a under root 2a cancel out, 16a square, from under root the sine, this is cos square theta, the square root is cos theta only, so cos theta under the square, so it's sine of integration. The sine of integration 0 to pi by 2, I'm sorry, 0 to pi by 2, 0 to pi by 2, cos theta is from this and this cos square theta, into cos theta only left over d theta. Okay, so this is nothing but 16 a square 0 to pi by 2, it is cos square theta d theta. Okay, if I just put cos square theta sine 0 theta, no problem, sine power 0 theta, and opening this by gamma function formula, which is same thing, 16a square cos square theta is gamma 2 plus 1 3 by 2, gamma 1.2, because 0 plus 1 sine 0 is 0, sine 0 is 1 over 0, divided by twice 2 plus 2 4 upon 2. Okay, since let me write here sine of integration 0 to pi by 2, okay, sine 0 theta cos m theta d theta is equal to gamma 1.2, because 0 plus 1 upon 2 into gamma m plus 1 upon 2 divided by twice gamma m plus 2 upon 2 only. So similarly we have done this. So it is finally what the value. Let me solve it further. So here we obtain 16a square, gamma 3 by 2 is 1.2, gamma 1.2, and this is gamma 1.2 divided by gamma 2 means factorial 1, that means 1 only, so 2 into 1. So this is 2 to the 4 and this 4 for the 16, so 4a square into gamma 1.2, gamma 1.2 is under root pi, root pi into root pi, that means pi, so 4 pi a square is the answer. This is the area for pi square, for pi a square is the area of the required curve here. Okay, area of the curve, required area of the curve is 4 pi a square. Simple answer, 4 pi a square, because gamma 1.2 is under root pi, this is root pi, and this 4a square we have taken, 2 2 is 4, and 4 4 is 16, so 4a square. 4 pi a square is the answer. Okay, so question number 15. Now let me talk about 16th question, guys. Question number 16th now. What does it say? Let me take it the last question. Trace the curve y square. Okay, so 16th question, which is y square into a plus x equal to, this is a minus x whole cube. Again, this is y square. X is not even powered, but y is even powered, so it will be symmetric about x-axis. So the curve is symmetric about x-axis. Here, let me solution. First point, the curve is symmetric. The curve is symmetric about x-axis. X-axis. Okay, as y is even powered. As y is even powered. Second point, it will pass through the, no, it will not pass through the origin. It will not pass through the origin. So this is the independent term, aq will be an independent term from here. So it will not pass through the origin. It will not pass through the origin. Third point, so equating y equal to 0. So, sorry, this, okay, smallest degree term, if I find out y square equal to, here, y square is equal to, yeah, y square is equal to a minus x whole cube upon a plus x. Now we see here that x equal to minus a, here at x equal to minus a, y square tends to infinity, or y tends to plus infinity and minus and plus minus infinity, let me take. That means x equal to minus a is the asymptote here. So x equal to minus a is the asymptote. Is asymptote here. Okay, why asymptote? Because as x decreases from, this is x equal to minus a, 0 to minus a, y tends to plus minus infinity. But if I put here x equal to minus a, it is 0 here, so y square is this infinity, that means y equal to plus minus infinity. So at x decreases, y decreases from 0 to infinity, and plus infinity increases also. That is the asymptote here. And at what point x equal to a will be the meeting point here, and a minus x equal to 0. If I solve it for, then a minus x equal to 0. A minus x, and fourth point, a minus x equal to 0, or x equal to a, that means that is a0 is the point. If y equal to 0, then we take a minus x equal to 0. At y equal to 0, a minus x equal to 0, we have substituted y equal to 0 here. So a minus x equal to 0. That means the curve will meet the x-axis. The curve will meet the x-axis, the axis of x at a0. Simple. Let me first draw the curve. So the curve is of this kind. Let me take this. This is the x-axis, y-axis, this is x-axis. This is the point x equal to a. Okay, and here it is x equal to minus a. So what do we see? If I take this asymptote here at x equal to minus a, curve is starting from this point. Okay, because curve is meeting at this point. curve is meeting at this point, we can take this as, this is the curve here meeting. Okay, and asymptotes at this. So area we have to find out. This area, total area. So again, if I take this strip here, this strip is from minus a to plus a. If I take the limits here, minus a to plus a is the limit. So area of this, area of the required curve, or required area of the curve, area of the required curve, or required area of the curve, whatever. Okay, area of the required curve is equal to 2 times area of this curve. Let me take this is A, here it is A dash, B and B dash. If I take A dash B, this is twice, let me take, into area of A dash B. That means twice into minus A to plus A is minus A to plus A, or A to minus A, minus sign will be there, no problem. But area we have to find out. So minus A to plus A we will take, but curve is starting from this point. So limits must be A to minus A. But I'm sorry, minus A to plus A, negative sign will come, no problem. But numerically the area will be there. So this is again y into dx, because this is dx here. This is y into dx. So area is twice minus A to plus A, limits are. So now let me take what is the area of this. So y is here, let me substitute twice minus A to plus A, limits, and y is here, yeah, a minus x whole power 3 by 2 divided by a plus x square root. Okay, so first let me rationalize this. A plus x and a minus x, if I multiply the numerator and denominator, that will give us something. So then we will substitute some value. Okay, so let me first multiply by a minus x, unroot a minus x in the denominator and numerator. So rationalizing this first, that will give us unroot a square minus x square, then put x equal to a sin theta, and we will solve it. Now let me solve this equation. So this is the curve here, don't forget. Now area is this. This is the area. Main objective here is find the area under the asymptote and the curve. So from curve is from a point to a dash, and asymptote is at x equal to minus a. That we have to just solve here. This is the area. So let me solve this equation. So finally the area of this curve, let me find out. So therefore this is twice minus a to plus a. This is a minus x whole power 3 by 2 dx. This is dx, sorry, divided by under root a plus x. Okay, let me change the marker. So this is the value. Now twice minus a plus a, rationalizing this. So rationalizing first, let me this. Rationalizing this by multiplying numerator and denominator by numerator by under root a minus x. If I multiply, so it will give us, yeah, because 3 by 2, that was the whole cube, the value of whole cube. So it will be under root a minus x here, a minus x whole cube it was in the numerator, where it is a minus x whole cube, no problem, into under root a minus x a plus x. Or if I substitute x equal to a sin square theta, no, still it is there. Okay, no problem. So under root a minus x, if I substitute, it will be a minus x whole power 3 by 2 into a minus x whole power half, no problem, divided by this is under root a, this a minus x a plus x, that means a square minus x square. Okay, so this is not a problem. Now in the numerator we are having a minus x whole power 2 whole square. So in the numerator we are having twice minus a2 plus a. Here it is a minus x whole power 2 only, because 3 by 2 plus half means 4 by 2, that is square, into dx divided by under root a square minus x square. So putting x equal to a sine theta, therefore differentiating it with respect to theta, we get dx equal to a cos theta d theta. Now limits here -1 is minus pi by 2. But -1 is for sine minus pi by 2. That means minus pi by 2 to plus pi by 2. So limits here at x equal to a, theta equal to pi by 2. At x equal to minus a, theta equal to minus pi by 2. No problem. Limits are 2 minus pi by 2 to plus pi by 2. If I make it 0 to pi by 2, then twice we have to multiply. That we will do later. No problem. This is, if I open this whole square, we will get as a square plus x square minus twice ax, twice ax only. Now if I substitute this value, it is dx, sorry. Now I have to substitute this value. Or we could put that a sine theta, no problem. Then could square it, no problem. It is nothing but a minus a sine theta whole square divided by, now this is under root a square minus a square sine square theta. Here it is twice, only a cos theta d theta. It is a cos theta d theta. No problem. So we obtain here, this is 4 times, because 4 into 0 to pi by 2 now limits. Okay. In the numerator we are having a minus a sine theta whole square. Let me divide in the denominator we will get a square out of the square root, that will come out as a. Under the square root will be 1 minus sine square theta, that means cos theta. So this 1 minus sine square theta is cos theta, that I am doing number of times. Please just understand this. It's nothing but under root 1 minus sine square theta, that means cos square theta. Square root and square cancelled out. Cos theta, and this is a cos theta. So this cos theta and this a cos theta both cancel out. Only this is d theta. This is the value here. Let me further resolve it. So what is the final answer? Let me solve it here. This is equal to 4, 0 to pi by 2. And this is a minus a, that means a square if I take outside, it is 1 minus sine theta whole square into d theta. It is nothing but 4 into 0 to pi by 2, a square is outside, whole square open, 1 plus sine square theta minus twice sine theta into d theta. Now sine square theta can be replaced by 1 minus cos 2 theta upon 2. Then we can integrate it. Okay, so this is 4a square 0 to pi by 2. 1 is integrated as theta. Okay, let me first write it as, this is 1 minus cos 2 theta, sorry. This is 1 minus cos 2 theta upon 2. Sine square theta is minus 2 sine theta. Now we can integrate them one by one. This is 1.2 plus 1, 3 by 2. So it is 4a square. It is 3 by 2. This 1.2 and 1. 3 by 2 into theta minus sine. Cos 2 theta upon 2 is there. So cos 2 theta is integrated sine 2 theta upon 2, that means 4. Because 2 is there. Cos 2 theta is positive sine 2 theta upon 2. But 2 is already there, so it is upon 4. And this is minus sine now. This is sine theta is minus cos theta, means plus 2 cos theta. Now limits are 0 to pi by 2. Okay, now let me solve it. 4a square theta is pi by 2 only. It's 3 by 2 into pi by 2 minus sine. Sine pi by 2 is sine 0. At 0, this is at both limits pi by 2 and 0, it is 0. So this is 0 here. Plus 2 cos theta. It will be minus 2 only, because at pi by 2 it is 0, cos pi by 2 is 0. At 0 it is minus minus 2 here, so it is minus 2. So lower limit cos 0 is 1, so, but it will be minus sign, so 2 only. Okay, now let me multiply this inside. So this is 3 pi by, so 4a square into 3 pi by 4 minus 2. Okay, so 4 cancel out. If I let me take LCM here, so this is 4a square, within bracket it is 3 pi minus 8 upon 4. 4 cancelled out. So it is a square into 3 pi minus 8. Final answer is, this is the area here. Final answer is, let me write it. So finally answer is a square into 3 pi minus 8. This is the answer here. Because 4 in the denominator and numerator cancel out. So a into 3 pi, or 3 pi a square minus 8a square. It can be written as 3 pi a square minus 8a square. Okay. Alright, so this is the area of this curve. 16th question is finally done. Okay, so 16th question we have taken as the answer. It's coming as 3 pi a square by minus 8a square is not coming. Okay, it is 0, I think. At 0 it was 0. Well, it was at 0 it was minus pi by 2. I think minus 8a is not coming. Minus 8, only 3 pi by 4 is coming. It means last value, this is negative. This value is coming as 0. This value is not there. Only answer is 3 pi a square. So there may be some mistake here. The limit, we substituted pi by 2 to 0. At cos 0 was 0. And the second point, it was at 4a square. If I do it again, then it can be, so it is negative. Some mistake has committed. So I mean 8a square is not coming. It means 3 pi a square is the only answer. I think this I calculated previously one time in the class. So I remember the answer is 3 pi a square, not 8a square. If I just do it again, let me take that again. This was twice into minus a2 plus a. So answer was a minus x whole power 3 by 2. It was 3 by 2 power. Okay, no problem. This was a plus x under root into dx. This was the value here. Then we make it as 4. This is 4, 0 to a, no problem. Because this is